In this video, we will show you how to train a model. Let's start by defining a problem we want to solve. Let's train a model to simulate a cosine function. In a neural network, we will define an input layer as a 1D tensor and the output layer of the model will also be a 1D tensor. For this example, each output will be the cosine of each input. To do this, we will use an example of training dense neural network models available to users. Deep learning is always done in 3 key steps: designing a model, preparing the data, and running the neural network model. In this video, we will focus on the data and the process of training. The design stage of the model is explained in another video. Now let's talk about cosine data generation. This function available in the deep learning library is a 2D array generator of cosine data. Recall that our model has only one one-dimensional tensor consisting of 6 values for input data layer. In our case, the forward function will expect for this model a 2D array. Since we are sending the data in batch, we always add a dimension representing the data group. A dimension for the batch and 1D array representing each expected 1D tensor. As data are sent in batch, the generator creates a table of batches. At the end, the generator produces an array of batches and each index corresponds to a batch of data. So the training part is composed of one batch loop, which consists of forward batches one by one, evaluate the precision and backward. After any loop iteration, we update the model with a shift registry. Finally, our loop is nested in the epoch loop. At each epoch, we observe the result of the model by transmitting all the data in one batch and displaying them in a graph. The prediction of the output data will be the result of this batch. 100 one-dimensional tensors of size 6. We reshape this 2D array into a 1D array and that's it. Now it's time to execute this cosine training model. Congratulations, you trained your first model.